In 7.3, we are adding and subtracting rational expressions. So first, let's review how to add and subtract fractions without a calculator. So one of the keys is you need the LCD, which stands for lowest common denominator. So LCD. Once again, lowest common denominator. And that's because when you're adding and subtracting fractions, you need the denominators, so the bottoms, to be the same. Right now, these are not the same. So first we want to identify, well, what would be the smallest number that could be the same denominator? And that is 5's our smaller number, and we can multiply 5 by 3 to make that 15. So our LCD would be 15. So now if I multiply that denominator by 3, I also have to multiply the numerator by 3. I'm keeping 2/15 the same because it already has that denominator of 15 plus 3 times 3 is 9 over 5 times 3 is 15. Now I can add these. So I'm going to add my numerators. 2 plus 9 is 11, and your denominators stay the same. And that is our answer. So we're going to apply that idea, but with rational expressions. So here's our step. Factor if necessary, and cancel common factors if possible. Then look at your denominators. If they're already the same, then add or subtract the numerators and place the results over the common denominator. But if your common denominators are different, you need to find that LCD, change the expressions according to the LCD, and add or subtract numerators, and then place the result over your common denominator. Reduce if possible, and you leave your denominators in factored form. I know that sounds like a lot, but I'm going to break that down here through a few examples. So, step 1, factor if possible, or if necessary. And when we look at those denominators, x plus 3 and x minus 2, we can't factor them. Now, these are not the same denominators, so we can't subtract yet. So this has an x plus 3, and this has an x minus 2. Now, that means our lowest common denominator is going to be x plus 3 times the quantity x, whoops, it's a minus 2. X plus 3 times the quantity x minus 2. So now I'm going to see what is each expression missing. So our x plus 3 is missing that x minus 2. So I'm going to multiply the numerator and denominator by x minus 2. And then when I look at my second expression, 5 over x minus 2, that's missing the x plus 3. So we multiply our numerator and denominator by x plus 3. And now when I multiply, I'm actually going to multiply. So x times x is x squared negative 2 x minus over, we have x minus 2 and x plus 3 minus 5 times x is 5x, and 5 times 3 is 15. over our denominator, x minus 2 and x plus 3. Now we can subtract, but we want to be careful here. So now that we've figured out what we have to multiply each side by so that we have our lowest common denominator, we're actually going to multiply our numerators out, but when I do that, I'm going to make sure I put them in parentheses. So I'm doing x times x, which is x squared, and negative 2 times x, which is negative 2x, minus 5 times x, which is 5x, and 5 times 3, which is 15, over our LCD, which is x minus 2 and x plus 3. Now I'm subtracting in our numerator, so this is going to become a positive, and my signs after that change. So now I'm doing x squared, and there's nothing I can combine that with, so x squared. Negative 2x plus negative 5x is negative 7x. And then I have that minus 15 over x minus 2, x plus 3. Now we can't simplify that even further, so this is going to be our answer, but we still need to state those restrictions. So looking at our denominator here, x minus 2 can't equal 0, x plus 3 can't equal 0, so x can't equal negative or positive 2 or negative 3. So here's our final answer. So here's another problem. Perform the indicated operation and state the restrictions. So we're subtracting. Our denominator's already factored for us, so we don't have to worry about factoring the denominator. Then we look, we have x plus 5 and x minus 3, and x plus 5 and x minus 3. So we have a common denominator already, so now we're just going to go straight into subtracting. So I'm going to rewrite this to x plus 7 minus x plus 10. Putting that in parentheses because I need to remember to distribute that negative sign. Then over our common denominator, that negative becomes a positive and every sign after it changes. And now combine like terms on our numerator. 2x plus 2x plus negative x is x. 7 plus negative 10, negative 3 over x to the, or x plus 5 and x minus 3. And I can cancel x minus 3 and x minus 3. Now when that happens, we have a 1 in our numerator over x plus 5. And then don't forget your restrictions. X can't equal negative 5 and positive 3. All right. Perform the indicated operations, state the restrictions on the variables. So, denominator's factored for us already. We look, x plus 2 and x minus 5, x plus 2 and x minus 5. So we can begin subtracting. rewrite the numerator together using parentheses. 2x plus 7 minus x plus 5 over x plus 2, x minus 5. Combine like terms in the numerator, so that negative's becoming a positive, and all our signs after become the opposite. 2x plus negative x is x. 7 plus negative 5 is positive 2 over x plus 2, x minus 5. Cancel x plus 2 and x plus 2. So we have a 1 in our numerator over x minus 5. And our restrictions, x can't equal negative 2 or positive 5. Continuing, now we have an addition. 2x plus 3 and 2x plus 3 is our denominator, and those are the same already. So we're just going to go ahead and add x plus 1 plus 3x minus 8 over 2x plus 3. Now, since we already have an addition sign, we don't have to do any sign changing. We're just going to combine like terms. X plus 3x, 4x, 1 plus negative 8, negative 7 over 2x plus 3. Don't forget your restrictions. X can't equal negative 3 halves. Now, once again, I'm getting that from setting that denominator equal to 0 or not equal to 0, and then solving for x. So that's where that negative 3 halves came from. All right, perform the indicated operations, state the restrictions on the variables. All right, so I take a look at my denominators in this one, they're not the same. So I'm going to go through those steps. 1, factor. So 2x can't factor. 2x plus 6, we can factor out a 2x, and then we get x plus 3. So if we look, the expression on the left, 3 over 2x, already has that 2x. It's just missing the x plus 3. So our LCD is 2x and x plus 3. So since that expression on the left is missing x plus 3, I need to multiply both sides, or not both sides, sorry, the top and bottom by x plus 3. So we get 3x, 3 times 3 is 9, plus 9, plus x over our LCD, 2x times x plus 3. Now we have a plus sign here, so no sign changing. I can just combine like terms in my numerator. 3x and x make 4x plus 9 over 2x times the quantity x plus 3. We leave our denominator factored. We can't simplify any further, so we're just stating our restrictions. X can't equal 0 or negative 3. All right, and that is adding and subtracting rational expressions.